So the first thing I like to do in solving these problems is to break the velocities into the component along the line of impact and perpendicular. So it's a little hard to see which side is going to be 3/5 and which side is going to be 4/5. So I'm going to exaggerate it. So here's the angle, very tilted. So if that's the 10, okay, we want the part perpendicular to the impact and along the impact. And so you can see that the part that's along the line of impact is the small side, and the one perpendicular is the long side. So that's going to be 3/5 of 10, and that's going to be 4/5 of 10. And this one is going to be 3/5 of 8, and that'll be 4/5 of 8. So let's redraw that along the line of impact. So I'm going to tilt it this way. So there's B and there's A, and so we have for B, it's going at 3/5 of 8 that way and 4/5 of 8 that way. Let me do all the calculations and come right back. Okay, so 3/5 of 8 is 4.8, and 4/5 of 8 is 6.4. This one is easier, so we have 3/5 of 10 going that way, which is 6, and we have 4/5 of 10, which is 8, going that way. Okay, so that's before. And so after, the perpendicular velocities do not change, so that's 6.4 and 8. And I'm just going to assume in this case that they're going apart. And so that will be VA, I'll call it X2, and that will be VBX2. Okay, so that's before and after. So first of all, we need two equations for those two unknowns. And the first equation is conservation of momentum. Okay, so the masses were 12 kilograms for A and 8 kilograms for B. So that was 12 kilograms for A and 8 kilograms for B. Okay, so let's do the momentum before. We'll say to the right is positive. So B has a velocity of 4.8 meters per second, and its mass was 8 minus. A has a velocity of 6 meters per second along the impact line, and its mass was 12. And that will equal, afterwards, we'll say VBX2 negative, because it's going to the left, times its mass of 8 plus VAX2 times its mass of 12, and it's going to the right. So I'm going to simplify that and come right back. So that comes out to minus 33.6 equals minus 8 VBX2 plus 12 VAX2. So the second equation is the impact equation. And the impact equation is just that V apart equals E times V together. So the way I've drawn it, VAX2 minus VBX2, because VBX2 is going to the left, will be VAX2 plus VBX2. That's how much they're going apart totally. The coefficient of restitution E was 0.75, and the velocity that they're coming together is 6 plus 4.8, which is 10.8. Okay, so I'm going to simplify that and come back. Okay, so we have 8.1 equals, let's see, what did I have? VBX2 plus VAX2. Okay, so I'm going to rewrite both equations here. So we have VAX2 times 12 minus 8 VBX2 equals minus 33.6, and we have VAX2 plus VBX2 equals 8.1. So I'm now going to solve that on my calculator solving two simultaneous equations. So I get VAX2 is 1.56 and VBX2 is 6.54. Okay, and so now all that's left is to get the total velocity. So B, by Pythagoras theorem, is square root 6.54 squared, and B had a y velocity of 6.4 squared. Okay, and then VA is square root of 1.56 squared plus 8 squared square root. And let me calculate those. So I get 9.15 for the total velocity of B, and I get 8.15 for the total velocity of A. And just write that in there. I'll go double check with the solution in a little bit. So, hooray, I got both of those correct. So in this problem, there's a typo. It says the system is at rest